डिस्कस करूंगा as because you know that we are already moving into the discussion towards rotational motion, so that's why where we will get introduced with various terms. Angular velocity is one of them. So in many cases we will be requiring to know angular velocity of a dimensional body about a given position or about a given axis. So here we will try to learn something about angular velocity. How can we relate or how can we develop the state of angular velocity value of one point about the other point on a dimensional body when nothing is given about the angular speed or angular motion. Nothing is said about initially having any existence of angular motion. Only suppose the translatory kinematics mechanism is given, the information said about the dimensional body is only in terms of the linear velocities. So by using the linear velocity, how we can reach the term of angular velocity? We need to learn this, we need to learn the concept. So that's why let's have a discussion on this. So here we are discussing how to use linear velocity in defining angular velocity, and that is for a rigid body. So let us the discussion proceeds from this part. Here I have taken a one dimensional rigid body, that is a rod whose length I have taken as 4 meter, mass taken as 8 kg, and at its end A and B the velocities are like this. At end A velocity is v1 whose numerical value is known to us 2 meter per second, and it makes 30 degree with the position of the rod, right? Whereas on the other end, that is at end B, there is some velocity value v2 which is unknown to us. We don't know the velocity value of the rod at its end B, but we do know the direction of it. It makes 60 degree with the position of the rod. So based on these informations, we need to know the angular velocity of end A about the end B. So here first what we can do, according to the given information, if I redraw the situation of the rod again, so I can say the rod is having here the unknown velocity v2 at end B. So on resolution, on the basis of the direction said about the v2 velocity which is 60 degree, right, I can write down here it is v2 cos 60, and here it must be v2 sin 60, right? Is there any problem? I don't think so. Okay, so now going to the other end A, where the velocity value is v1 which is making 30 degree with the rod. So resolving that velocity, one along the rod and one perpendicular to the rod, so I get here in this side it is v1 cos 30. So as we know the value of v1 which is 2 into root 3 by 2. v1 is value is given 2, so ultimately this value is equal to root 3 meter per second, and here on the other side perpendicular to the rod it is v1 sin 30. So putting the value of v1 and sin 30, it is 1 meter per second. So we know the absolute magnitude of the velocities at end A along the rod as well as perpendicular to the rod, whereas on the other end, that is at end B, we don't know the exact magnitude, but in terms of the v2 we have expressed the magnitudes along the rod and perpendicular to the rod. So now here we can comment on one very important thing. Since rod AB is a rigid body, therefore at its ends velocity along the rod must be same, because if the velocities are same, then only it is possible for the rod to maintain its rigidity, and hence it will survive with its given dimensional value which is its length. So that means from this part we can write down v1 cos 30 which is root 3, that must be equal to V2 cos 60. So since V2 cos 60 means it is V2 by 2. So from this part we got the value of numerical value of V2, which is 2 root 3 meter per second. So first, this concept has helped us to know the exact magnitude of the velocity V2, which was unknown initially at the end B. So now, as we need to know the angular speed of the rod about end B, so see that now to calculate omega A about B, as because we need to know the angular speed at end A about the end B, so that means we need to know the omega AB. So to calculate omega AB, we need to have concern with the linear velocities which are appearing perpendicular to the rod, right? So this is the ends and these are the perpendicular velocity. In this end it is 1 meter per second, and here at this end it is V2 sin 60, and we got the value of V2 as 2 root 3, that into sin 60 root 3 by 2, that means it is numerically 3 meter per second, and length of the rod is given 4 meter. Okay, so we can calculate omega A about B, provided we get the VA about B divided by the length AB. So velocity at A about the end B being perpendicular, because we are discussing on the term perpendicular to AB, so it is velocity at the end A about B will be 1 minus of minus 3 divided by the length, which is 4 meter. So it is 4 by 4 is 1 radian per second. So angular speed of the rod at end A about end B is developed as 1 radian per second. So that means the equivalent thing we can write down, it's like this. So rod is something, it's happening like this. This velocity what we calculate, what we got as VAB, using this length L, which is 4 meter, about the end B, the end A, forming an angular speed omega AB like this. So this is the way we can move into the mechanism of rotational motion by the help of translational motion. So lots of conceptual discussions I will do in my next videos. Based on the rotational dynamics, where we will see that how the character of translational motion is used to move into the character, to knowing the character of rotational motion. So it's a very interesting video, very important one. I would suggest to watch this video very carefully, give your 100%, and keep watching my next videos so that you can learn few unmatched and untouched concept of rotational motion, and I can assure you these concepts will definitely help you to take yourself to a very strong position in mechanics, and hence that will lead you to crack